Yeah, good morning, students. Welcome to this class on computer organization and architecture. So today we would like to discuss about the instruction execution. So which will be falling under this unit 2 topic. Now I would like to share my screen. Yeah, the classroom discussion topic on instruction execution. The lecture objectives of today's session will develop the students' knowledge on what are the different steps involved in instruction execution. So what are the different steps involved in the instruction execution? So instruction execution. For example, consider this following instruction related to this load instruction. So this load R5 comma x of R7. So in this particular instruction, what is the addressing mode we have used in this? Anyone please can identify? So because here the second operand we have used is x of Ri. So when we have used the second operand as x of Ri, then this type of register addressing is called it as index addressing mode. So this instruction load R5 comma x of R7, which uses this indexed addressing mode to load the word of data from memory location x plus contents of R of 7 into this register R5. Now we will see how this processor will execute this particular load instruction. So the execution of this instruction will involve these following steps. The first step is it will fetch the instruction from the memory. Then it will increment the program counter. PC content will be incremented by word length. Then it will decode the instruction to determine the operation to be performed, and also it identifies what are the operands are there. So that is the third step. Then the fourth step is it will read the contents of the register R7. Add the immediate value of x to the contents of R7 to get the effective address. Then use the sum x plus contents of R7 as the effective address of the source operand, and the read instruction is executed to read that location from the memory, which is identified by effective address. So load the data received from the memory into the destination register R5. So the next step is it will load the data which is received from the memory location, which is identified with the effective address, which is equal to x plus contents of R7 into the destination register R5. So these are the steps that are executed when we are executing the load instruction given as this particular example. Now we will assume that the processor has 5 hardware stages, so which is commonly used arrangement in the RISC style processors. So 5 stage hardware we are considering in the instruction execution. So which is followed by your RISC processors. So execution of each instruction is divided into 5 steps such that each step is carried out by one hardware stage. Fine. So we are considering 5-step instruction execution. For each step one hardware will be there. So that is the reason it is called it as a 5 stages hardware, which is used in RISC style processors for the instruction execution. So in this previous example, which we considered this load instruction. So in that load instruction, so we have this fetching and executing the load instruction can be completed how as follows. So first is that we will fetch the instruction and increment the program counter. This is the first step that what we have seen. Now second step is we are decoding the instruction and read the contents of register R7 in the register file. Third step is it will compute the effective address. Then fourth step is read the memory source operands. If the operands are memory operands, then we have to read that operand values from the memory. Then the fifth step is load the operands into the destination register R5. So these are the 5 important stages which are used in executing of this particular instruction. What we have seen earlier, load of what we are calling it as okay, load of R5 comma x plus okay R5 comma x of R7, okay, x of R7, where x is nothing but we are calling it as a displacement or offset we are calling it as. So in order to execute this particular instruction, the processor is going to use these 5 steps or 5 stages we can call it as. Okay, fetching the instruction and then incrementing the program counter, decoding the instruction and read the contents of this register, compute the effective address, read the memory source operands, load the operand into the destination register. That is what we are doing here basically. So next, if you consider the second category of instructions, which we are calling it as arithmetic and logic instructions. So if you consider this arithmetic logic instructions, so which involves the arithmetic and logic operations, which has to be executed in a similar manner how the load instruction is executed. But there are certain differences between executing this arithmetic logic instruction from the load instruction. So the two important ways in which this load instruction is differing from this arithmetic instruction is there are either two source registers or a source register and an immediate source operand in the instruction. So that is this arithmetic and logic instructions, if you take it as the operands are either the two source registers are there or a source register and an immediate operand will be there. So no access to memory operands is required whenever we are executing this arithmetic and logic instructions. So no operand, memory operand is there in that particular instruction. So for example, if you consider an instruction add R3, R4 and R5. So in order to execute this instruction, the instruction execution will follow these following steps because add is an arithmetic instruction. So the following steps are, the first step is fetch the instruction and increment the program counter as usual with the load instruction what we have seen in the previous example. Now the second step is also decode the instructions, and once it is decoded that it will identify what type of instruction it is, whether it is a load or store or whether it is an arithmetic or logic instruction like that, and then it will identify what type of operands are involved in this instruction. So that is nothing but decoding of the instruction. So once it identifies that in the decode step the operands are of register type, then it will read the contents of the source registers. Now in this particular instruction, the source registers are R4 and R5. So third step is then compute the sum or contents of R4 plus R5, and again the result will be loaded, the sum result will be loaded into the destination register R3. That is the load the result into the destination register R3. So these are the steps that are followed here. So the add instruction does not require access to an operand in the memory and therefore could be completed in 4 steps only instead of 5 steps which are needed for the load instruction what we have seen earlier example. Fine. So the arithmetic instruction in this particular example, the add instruction, which is involving this memory register operands, they are executed in 4 steps. So the add instruction should be extended to 5 steps pattern along the steps of the load instruction. Since no access to memory operands is required, so we can insert a step in which no action takes place between steps 3 and 4 above, because the add instruction would then be performed as follows. Because we are making use of the 5 stages hardware to perform the instruction execution. So that means here any instruction, any type of instruction has to follow those 5 stages. So if a particular stage is not following, means that we have to make that particular step as a dummy step so that we are not performing any action that could takes place during that particular step. So that is the reason here we are seeing this add instruction. So in 5 different steps, how we can rewrite that, which we have written as a 4-step execution process. So the first step, if you consider that, it is fetching the instruction and incrementing the program counter as usual. And then second step is also the same, decode the instruction and read the register contents R4 and R5. So third instruction is computing the summation contents of R flows R5. Then the fourth step in that we are not doing any action, no action. Then the fifth step is we are loading the result into the destination register R3. So this is what we are rewriting this 4-step execution which we have written for add instruction into 5 steps, because we are adding a no operation steps, we are adding wherever we require that, wherever it is suitable. So if the instruction is using an immediate operand in the add instruction, for example, okay, add R4 comma R3 comma R4 hash 1000. So here this is an immediate operand. So if this arithmetic instruction is using the immediate operands along with the register contents, then how this instruction will be executed? So this 5-step sequence of execution will be modified like this. Once this instruction is loaded into this instruction register IR, so the immediate value is available for use in the addition operation. So the same 5-step sequence can be used with the step 2 and 3 modified as no operations. Okay. So that means the step 1 will be as usual, fetching that instruction and incrementing the program counter. And step 2 is now decode the instruction and read the register R4 value, because one operand is available as immediate value and another operand is available in the R4 register. So we have to read the register R4 value. Then the third step is we have to compute the sum, which is equal to contents of R4 plus 1000, the immediate operand value. Fine. So these are nothing but second and third step will be modified as in the previous steps which we have written for this particular add instruction. So this fourth step is no action, and the fifth step is nothing but it will be load the result back into the R3 register. Fine. So next, third category of instruction, we have to discuss how the store instruction type is going to be executed. So this is the store instruction here. So the 5-step sequence used for the load and add instructions is also suitable for store instruction execution, except that the final step of loading the result into a destination register is not required. Okay, so just we are changing that final step. So the hardware stage which is responsible for this step takes no action. That is, this final step is written as no action. So for example, consider this instruction store R6 comma X of R8. So which stores the contents of R6 register into a memory location X plus contents of R8. So this gives you the memory location address. So where you have to store this register R6 content into this memory location. So it can be implemented. This instruction execution can be implemented as follows. So the first step is we have to fetch the instruction and then increment the PC. Second step is decode the instruction and then read the register contents R6 and R8 and then compute the effective address which is equal to X plus contents of R8. Then fourth step is we have to store this contents of R6 register into the memory location. Fine. So once it is done, the fifth step, there is no action needed. Fine. So these are the 5 steps which we are executing as the store instruction execution steps. So after reading the register R6 in step 2, the memory address is computed in step 3 using the immediate value X in IR register. So in step 4, the contents of R6 are sent to the memory to be stored. So in step 5, no action is taken. Fine. So now up to this point, we have discussed about how the load instruction is executed using 5-stage instruction execution process. Similarly, how arithmetic instructions like add will be executed. And the third important type of instruction which we have seen is store. How this store instruction is executed. What are the steps that are involved under 5-stage instruction execution. Fine. So coming to this point, so that is nothing but, so at this point, so you have a small question for you students. Please try to answer this question. So list the steps involved in the 5-stage instruction execution. Okay, so what are the different 5 stages that are followed in instruction execution? Anyone, any student, please can you list out what are the 5 different stages which we have followed in executing these instructions of 3 different types of instructions just now we have discussed. Okay, so this is the lecture level practice problem. So write the steps involved in execution of this instruction MUL R3 comma R4 comma R5. So which type of instruction it is? Anyone, which type of instruction is this? So MUL comes under arithmetic instruction. Fine. So what are the steps which are involved? 5 steps which are involved in executing this particular instruction. So you have to write this steps as similar to this what we have written. Okay, so as similar to this store. Okay, fetch, decode, compute the effective address and then store the contents. If no action is needed, then you have to write no action step. So like this, if you go for arithmetic logic instruction, so just now we have seen that the 5 steps here what are involved in execution of this instruction: fetching the instruction and incrementing the program counter, decode the instruction and read the register's contents, compute the effective address, and store the contents of the registers, and then if no action is needed, so we can go for this no action step. Fine. So thank you students. Now after completion of this today's session, so you must be able to write the steps involved in instruction execution pertaining to different types of instructions like load instruction, arithmetic and logic instructions, and then store instructions. You must be able to write all these 5 different types of steps involved in instruction execution. Fine. So thank you one and all.